Okay, so this is the last video on complex number, where today we are going to learn about polar form. Okay, so basically complex number can be written in two forms. The first one is the Cartesian form. So this is the Cartesian form that we learned in the first video of complex number. So this is Cartesian form. So what we are going to learn today is how to write a complex number into a polar form. So this is the polar form. So instead of writing down z equal to a plus bi, we want to write down in the form of z equal to r cos theta plus I sin theta. Okay, so one thing that you should take note is that whenever we want to write down our polar form, we have to make sure that the z is already in Cartesian form. So that is the most crucial step. You need to make sure that the z is in Cartesian form first before we can obtain our polar form. Okay, so for example, if let's say we want to write down 3 plus 4i in polar form, so the first one, you have to check whether are they in Cartesian form or not. Okay, so obviously 3 plus 4i is similar to the Cartesian form, z equal to a plus bi. So we already have I to the power of 1 over here, so that means z is already in Cartesian form. So my first step is already done. Then we have to calculate the modulus of z, and then we need to draw the Argand diagram. By drawing the Argand diagram, we can actually calculate the argument, and then we can actually write down z in polar form. Let me proceed with the step. Okay, so I already checked previously that 3 plus 4i is already in Cartesian form, so this step done. So now the modulus of z. So if let's say z is equal to a plus bi, then the modulus of z is actually equal to the square root of a square plus with b square. So now what do we have before this is z equal to 3 plus 4i. So that means the modulus of z is simply equal to the square root of 3 square plus with 4 square. So 3 square is 9, 9 plus 16, so this is square root of 25, which is simply equal to 5. So that is our modulus. So modulus, done. Okay, next. Okay, so now we have to draw the Argand diagram. So do make sure you have the axis ready. So the x-axis, we don't call them x-axis anymore, but this is actually the real part of our complex number, and then the y-axis, so this is actually the imaginary part. Okay, so before this, I give you z is equal to 3 plus 4i. So that means the real number is 3, the imaginary is positive 4. So real 3, imaginary positive 4. So that means this one here is our z. So you can take a ruler. It's supposed to look a little bit straight, but never mind. So that is your z. Okay, so that is how we draw our Argand diagram. So the reason why we need to draw our Argand diagram is because we have to determine where is our z. Is it z in the first quadrant, the second quadrant, the third quadrant, or the fourth quadrant? Because the formula for the argument will be slightly different depending on where the z is. So do make sure you check first quadrant, second quadrant, third quadrant, or fourth quadrant. Okay, so now let me proceed with the argument. Okay, so previously we have drawn our Argand diagram, and I already see that it's supposed to be in the first quadrant. Okay, so that means firstly let us calculate the alpha. Alpha is equal to the arctangent of the modulus of b over a. So before this, we have z equal to 3 plus 4i. So z is equal to a plus bi. So that means b is 4, a is 3. So alpha, the basic angle, is equal to arctangent of 4 over 3. Okay, so the reason why we have to put the modulus sign is because we need to make sure that our basic angle is always positive. So I don't want any negative angle, because otherwise it simply means that we are moving clockwise. So I don't want them to move clockwise, I want them to move anti-clockwise. So that is why always put the modulus sign, and then of course use your calculator, but do keep in mind that for the argument you should always use radian. So do make sure to change the mode in your calculator, change it to radian first before you calculate arctangent of 4/3. Okay, so by using your calculator, you should be able to see that this is 0.927 radian. Okay, so this is the reason why I told you that we need to know where is our z. So I'm gonna give you the formula for the first quadrant, second quadrant, third quadrant, and fourth quadrant. So if our z is in the first quadrant, then our argument normally denoted by theta. So theta is actually equal to alpha. So we simply gonna take this value over here. If the z is in the fourth quadrant, it should be theta equal to negative alpha. So we're gonna times them with negative. If we are in the second quadrant, so theta is equal to pi minus with alpha. In the third quadrant, so theta will be the negative of pi minus alpha. So as long as you can remember the first and the second quadrant, then you can simply times them with negative in order to obtain the third and the fourth quadrant. Okay, so now my z is actually in the first quadrant, so that means I know for sure what is my argument. Okay, so that means the argument of z, theta, is actually equal to alpha because we are in the first quadrant. So this is 0.927 radian. Okay, so now we're gonna take everything that we know so far to write them down in polar form. Okay, so in polar form, z is equal to r cos theta plus I sin theta. This is actually the argument that we calculate before this. Both of them are actually the argument, where the r is actually the modulus of z. Cos stay as cos, I as I, sin as sin. So you don't have to change them. You simply need to substitute the value for the r as well as the theta. Okay, so now to write them down in polar form, z is equal to r. So before this we have 5. So now cos 0.927 plus I sin 0.927. Okay, so that is our z in the polar form. Okay, so let us proceed with the next question. Okay, so find the polar form of 1 minus 2i times with 2 plus i minus with 5i. So like I told you before, in order to do the polar form, we have to start from the Cartesian form. So I don't have them in Cartesian form yet, because in Cartesian form, we must have them in the form of a plus bi. So I cannot have any mixture like this. So let us expand them a little bit and simplify them first. Okay, so 1 times with 2 plus I. So what do I have is 2 plus I. Negative 3i times with 2, so negative 6i. Negative 3i, positive I, so negative 3i square minus with 5i. 2 I minus with 6i, so this is negative 5i. Negative 5i, so this is negative 10i. Minus with 3. And then this I square is actually equal to negative 1. So we're going to have 2 plus 3, which is 5 minus 10i. This is z in Cartesian form. So now we can actually calculate our modulus. So the modulus of z is actually equal to the square root of 5 square plus negative 10 with a square. So this is 25 plus 100, so this is the square root of 125. Okay, so now we haven't learned how to simplify the set yet, so I'm going to leave them as this. But once we learn how to simplify the set, I'm going to simplify this. Okay, so now before we start with our argument, we have to draw our Argand diagram, because we need to check which quadrant we are in. Okay, so we have a positive real part, so it will be on the right hand side here, but a negative imaginary, so it should be below here. So this is our z. Okay, so now the argument, as usual, we have to calculate alpha first. So alpha is equal to arctangent of the modulus for b over a. So b is negative 10 over 5. So negative 10 over 5, this is negative 2. So this is simply equal to arctangent of 2. So we're going to ignore the negative sign because we do have them inside the modulus sign. Okay, so arctangent of 2, you're going to use your calculator, and then this one will give you 1.107 radian. Okay, so basically we are in the fourth quadrant. So do you remember the formula that I gave you before? If we are in the fourth quadrant, so that means our argument is equal to negative alpha. Okay, so now theta is equal to the negative of 1.107 radian. Okay, so now let us write them down in polar form. So z is equal to r cos theta plus I sin theta. Okay, so r is simply the square root of 125, and then cos of, so my theta is negative, I'm going to write them down inside a bracket. So negative 1.107 plus I sin negative 1.107. Okay, so that's it for example 2. Okay, so we are done with the polar form. Okay, so we have already finished the second subtopic in chapter 1. So I'll see you guys in the third subtopic of chapter 1. Bye bye.